Algebra 1, this is chapter 3.5. We are going to talk about arithmetic sequences as linear functions, because that's what they are. Yes, I'm recording. Guys, we're going to talk about a sequence today. A sequence is just a set of numbers in a specific order. 1, 3, 5, 7, 9, 11, etc., etc., etc. is a sequence. 1, the 3, the 5, the 7 are called terms of the sequence. So you have a first term, second term, third term, fourth term, and so on. That's how a sequence works. Now, what we have here, though, is we're going to talk specifically today about arithmetic sequences. And the arithmetic sequences are sequences where the difference between successive terms is constant. 1, 3, 5, 7 is a constant change. There's a constant difference. It's going up by 2s, right? I'm adding 2 every time. That difference, guys, in arithmetic sequence is called the common difference. And because the common difference is the difference between every set of terms. Successive means next to. First term to second term to third term to fourth term. They all have a difference that is the same. We call it the common difference. Now, one thing I will say is that we will call that common difference D. And to find that common difference, guys, always take your final number minus your initial number. When we're talking about final minus initial, it means the last term you're on, or say the term you're on, subtract the term before it. So term 2 minus term 1. Term 3 minus term 2. Okay? Now if you look at that nice gray box there, it talks about exactly everything I just said. Arithmetic sequence is a numeral pattern that increases or decreases at a constant rate called the common difference. Notice 3, 5, 7, 9, 11 is kind of like the one that I was talking about as an example. It goes up by 2 every single time. So we say that the common difference, D, is equal to 2. If I start at 33, go to 29, 25, 21, 17, you can see that it drops by 4 every time. That means it has a common difference of 4. Sometimes it's real easy just to look at our numbers and say, hey, I know it's going up by 2 or it's going down by 4. Sometimes, though, it's not that easy. It will not go up and then go back down. That it cannot do, because that would not be consistent. So it has to be consistent. It's doing the same thing over and over and over and over and over and over. Guys, notice that it has dot, dot, dot after it. What do you think that means? It keeps on going, right? It goes on forever. So what I want you guys to do, though, is I want you to use this idea of final minus initial when solving for the common difference. Our first example is to identify, is it arithmetic sequence, yes or no? And if it is, what would the common difference be? Guys, it's not enough to state it's a common difference, it's arithmetic sequence, by only testing one number. You have to test it multiple times or all of the times. Okay? So, this is how I want you to do that. We need to find the common difference between the negative 26 and negative 22. Does Is the number going up or down? How do you know it's going up? Eli?
It's a negative and it's increasing to go to positive.
Yes, it's negative number. Negative 26 is actually smaller than negative 22, even though 26 itself is bigger than 22. So I need to find the difference between those two. I need to find the difference between negative 22 and 18. And I need to find the difference between negative 18 and 14. If I can show all three of those differences are the same, I will say that this is an arithmetic sequence. And to show that, I am going to use final minus the initial. So if I start at negative 26 and stop at negative 22, my final number is negative 22 minus where I started, which was a negative 26. What would you say about subtracting a negative, though? I'm going to add. What's negative 22 plus 26? It's 4. Now, if I can prove the rest of them are adding 4, then we're good to go. Next one, negative 18 minus a negative 22. I need to add that. So negative 18 plus 22 is 4. And the last one is negative 14 minus a negative 18. So it's plus 4. Does it have a common difference? Yes. So D is equal to 4, and this is a yes. It's an arithmetic sequence, right? I'm going to pause the video, give you guys a couple seconds to try the other one. Okay, guys, let's do the differences. 4 minus 1 is?
3.
3, okay. Oh, wait, 9 minus 4?
5. Oh, this is not looking good. This is looking bad.
Okay, at this point, do we even need to test the last one?
Nope.
No! This is a no. Boom, gone.
That's it?
What was the point of writing no in the beginning?
I don't know why I crossed it out. But we didn't have to go any further, guys.
Correct.
Okay? It's saying, is this, and it's no. Why? Because, BC, because no common difference. No common difference. Okay? Easy enough. So let's go on and kick it up a notch. What if the next direction said, hey, it's not enough to say it's an arithmetic sequence. So you have to kind of show that in a way. But I want the next 3 terms. What is this term? That term, that term. This one, and this one. Make it longer. So, what is someone's idea on how to find the next 3 terms?
Follow the pattern.
Right, follow the pattern. But how do you get that pattern, Cade?
You can subtract the difference of two numbers together.
Okay, and you're on the right track. Yes, I'm going to use the difference. I'm going to find that difference. And then just extend that difference further, right?
Yeah.
Just keep doing that difference. So again, it goes back to, I need the difference to make sure that it's common, first of all. Negative 13 minus negative 15 means add. What do you get? 2. Negative 11 minus a negative 13 means add. You get 2. Negative 9 minus a negative 11, add, you get 2. So that means D is equal to 2, which means I'm doing what every time?
Adding 2.
So if I add 2, I now at
-7.
add 2 again,
-5.
add 2 again,
-3. -1.
and so on. But I only want 3 terms. Not that big of a deal, right, guys? And then they give you something like that with fractions. I'll give you guys a couple seconds to try that one on your own. So, we got to do common difference. Now, why is this common difference going to be okay for us? Why is this going to be okay? They have common denominators. If they didn't, you would have to get common denominators. That's 5/8 minus 7/8, which is what? Negative 2/8. Now, I could reduce that to negative 1/4, but unfortunately, everything else is in eighths. Why change it?
That's true.
Next one's 3/8 minus 5/8 is? Ooh, negative 2/8. I got to keep going, though. 1/8 minus... It's the same. So D equals negative 2/8. So what am I doing every time? Minus 2/8. You get? Negative 1/8. Minus 2/8. You get? And?
And negative 7/8.
Boom. Guys, are you guys feeling comfortable with this?
Yeah.
Okay, well, the next slide is
Difficult.
the meat and bones of this whole thing.
Meat and bones. I got none of that.
Okay, guys, pay attention. This is important. Pay attention. Guys, if I'm talking about arithmetic sequence, the coolest thing about it is that I can actually create a line equation. So, what we need to do first of all is think about the terms of a sequence as first term, second term, third term, fourth term, nth term. We use the symbols. The nth term means whatever term we want to talk.
N is a
So fifth term
variable.
would be fifth term. If I was talking about the 10th term, I would use 10
TH term.
term. The 100th term. N stands for any term. Okay? Okay, listen up. The first term we call A sub 1. Term 2 is A sub 2. A sub 3, A sub 4, ... all the way to the A sub n for the nth term. Okay? Nth term is whatever we're going to decide it to be. And so, what do we get? Is the fact that, would you guys agree, that the first term of a sequence is just the first term? The second term, because we found a common difference, would be the first term plus whatever that difference is, whether it's adding it or subtracting it. All right? Hence, over here they have 8. If the common difference is 3, 8 plus 3 is 11. Then I go to the second term, or the third term. The third term is just the first term plus 2 of the differences. So 2 times 3, which is 6, and 6 plus 8 is 14. Again, you notice I'm just adding 3 from the last one? But then when I go to the fourth term, I have to add 3 of those differences. The fourth term, or the fifth term, would add 4 of the differences. Yes, the 100th term, you would be adding 99 differences to the first term. Now, wait a minute. Do you guys start to see a pattern to the fact that this is the second term, but I'm only adding it once? This is the third term. I'm only adding 2 because it's always 1 less than the term I'm using or asking for. If I'm asking then for the nth term, A sub n, then it's the first term plus whatever that term is minus 1 times d. D is the common difference that you will establish. What this, guys, establishes is this formula. A sub n, any term you want, for an arithmetic sequence can be found by a sub n equals the first term, a sub 1, plus n minus 1 times d. And that is what it's saying in the box here. A sub n equals a sub 1 plus n minus 1 times d. You're taking the common difference one less times than the term you're looking for and adding that then to the first term. So what I'm trying to say is we can form a line equation or the equation of an arithmetic sequence just by knowing two things. One, the first term. Two, the common difference. If you know those two things, you got an equation. So, next slide. Write an equation for the nth term of the arithmetic sequence, -12, -8, -4, 0. Then, after you've done the equation, please tell me the ninth term. Then, graph it, please, using the first 5 terms. And 3, which term of the sequence will give you 32? So actually the numbering is off a little bit here. But, first of all, guys, if I'm given a sequence and I'm told that it's an arithmetic sequence, it means it should have a common difference. I say, find that common difference. What would the common difference be? Hopefully everybody can see that it's going to be 4, but we have to show our work. -8 minus a -12 is 4. Going down here, -4 minus a -8. Add, so it's 4. 0 minus a -4 means I have to add, which is, so they're all the same, so the common difference, D, is 4. Yes? Everybody established D is equal to 4. I've said on the last slide, we only need two things. The common difference and a sub 1, which is the first term. What's the first term? That is a sub 1. So to write my equation, guys, I'm going to write the generic form down. A sub n equals a sub 1 plus n minus 1 times d. Plug in a sub 1, plug in d, and you have an equation. What's the first term? Plus n minus 1 times 4. I now technically have the ability to find any term I want. Any. But guess what, guys? I could probably potentially simplify this. Will, what are you thinking?
Thinking that you can distribute, multiply the 4 by the f.
Yes, I can distribute. So would you guys agree that a sub n is equal to -12 plus 4n minus 4? And even from here, I should be able to simplify that. -12 minus 4? What is that? It's minus 16. There's your equation, guys. And now that I got an equation, that's the very, very first thing it says. Write the equation. Now we have to do step 1 or part 1 that says find the nth term. If I want to know the ninth term, it'd be a sub 9. That's a bad 9.
That's a beautiful 9.
A sub 9, which would equal 4 times 9 minus 16. What's 4 times 9? 36 minus 16. It's 20. The ninth term in this sequence would be valued at 20. Now guys, for the ninth term, it wouldn't be that hard to go 1, 2, 3, 4, 5, extra out there, right? So I got 1, 2, 3, 4, 5, 6, 7, 8, and then put one more. Would you guys agree that that would be the ninth term? I could have counted that out, and I kept on adding 4, couldn't I? Probably. But what if I would have said, hey, tell me the 101st term? It would take you a long time to do that. But guess what wouldn't take you very long? Putting it into the equation. Guys, we need to graph this with the first 5 terms. Right now, I only have 4. Right? What's the next term? Should be a 4. But how do I graph just negative 12, negative 8, negative 4, 0, 4? Let's think of it differently. Let's think of it as those are my y values. What do you think are my x values? What term is negative 12? 1. Negative 8? 3, 4, 5. You now have a set of points if you think of it as 1, negative 12. 2, negative 8. 3, negative 4. 4, 0, so on, so on, so on. Do not have enough room. 1, 2, 3, 4, 5. I'm gonna go by 2s, and I still don't have enough room for 1, right? If I'm gonna go by 2s on there, but only go by 1s on the x. 2, negative 8 would be there. 3, negative 4. And 0, right? And then one more, 5, 4. It forms a line. Hey guys, watch this. Okay. Careful. No, that's not it. That's not the trick. How far up does it go until it starts to move over? 4, because we're going by 2s. How far over does it go?
1.
What's delta y over delta x? 4 over 1, which is 4.
Oh my God.
What's the common difference?
4.
4.
This is so magical.
4. That's, wait. The rate of change is 4, aka the slope, which is in front of n. Interesting. Could there be a connection? I think so. Okay, guys, we just completed the equation 1 and 2. We still have to do part 3. Part 3, guys, I'm going to erase this work here because I need some room. I need the equation. So if it asks me for which term of the sequence is 32, does that mean I need to put 32 in for n? No. I'm looking for which one of them has the value of. So that means 32 is what comes out when what n goes in. Right? Which term? How do I figure this out? Solve for n. 48 equals 4n. Divide both sides by 4. N equals 12. The 12th term will be 32. Or you could have technically counted it out. But what if I would have said, hey, right, or which one has a value of 512? I'd rather use the equation than trying to count things out.
I did a lot of paper.
Okay, guys, any questions on that?
Yeah.
Homework is page 193, 1 through 7, 41 through 49. Okay, 1 through 7, guys, are the problems from this book, this section. 41 through 49, and I'm going to start to assign these every night, are the review. It's a mixed review at the end of every lesson that I have not been assigning, but I will start to do that now. So you have 8 problems of review, which is good because you guys are going to be seeing these things pretty soon.
Yeah.
Have a great day.